All right, math peoples, thanks for joining me again today. We're going to continue our journey along factoring. And today's topic is going to be called factoring, and we're going to continue factoring trinomials. But we're going to continue by taking something out called the GCF First is what this technique is going to be called. And GCF stands for greatest common factor. So it's just going to be a new technique as we go through our journey of factoring. So let's start with an example here. So let's say we're going to start with 3x cubed plus 6x squared minus 24x. And our goal is going to be to continue to factor. Okay, but this is a little different because right away we probably notice that, hey, each of these has an x term. Normally, as we've been factoring so far, we've been factoring things like ax squared plus bx plus c in this type of formation, which is called standard form. And this is going to be related to this, but we notice that each of these has an x, and only these two have an x. So what we're going to do to deal with that is we're going to factor out the greatest common factor. In order to do that, I need to ask myself what goes into all three of these terms. First of all, let's focus on what number. So when I look at 3, 6, and 24, what can I take out of all of those as a factor? And as a matter of fact, I want to take out the greatest thing I can take out of those, and that's going to be a 3. A 3 goes into this 1 times, 2 times, and 8 times. So what I'm going to do is I'm going to write that 3 on the outside of the parentheses. And then I'm going to look to the variable. And I'm going to ask myself, how many x's can I take out of all of these at the same time? And in order to take the x out, I have to be able to take that many x's out of all of them. And really what you can do is you can look for the least power. So the power on this x here is really a 1. And that means I can only take one x out of each of these. So I'm just going to put a plain old x right here. Again, that's x to the first power. All right, as I factor that out, I'm going to divide this 3x out of each of these. So when I divide 3x out of 3x squared, when I divide the 3 out, it's a 1. We don't normally write that in front of the variable. But when I take 1x out, that's going to leave me with an x squared right here. And let's just continue with each term. When I divide a 3 out here, that's going to leave me with a 2. When I divide out an x, it's going to leave an x there, menos. And I divide a 3 out, that's going to give me an 8. I divided the x out, that's not going to leave any x's for this. Okay, so now we've taken out the greatest common factor. That's the first thing we should always do when we're going to factor something. But now what's left is still factorable. So this is not in factored form because I can continue to factor this piece. And the way I would continue to factor this piece is through the box method because this is a trinomial that I can factor. I know there's an x squared and a minus 8. I know there's an x and an x. And I see these are 1s, which are much easier to factor. So I need factors of 8, which are going to be, or two things that make a product of 8, which is 1 and 8 and 2 and 4, that are going to give me a plus 2 out of these boxes. I think these are my candidates here because I'd have 2x and I'd have 4x. If I want plus 2x, I would make this the plus. I would make this the minus. All right, so in the end then, we want to write this in completely factored form. So in the end, here's what my answer looks like. I must include all factors. I must include this 3x. And then this trinomial I factored to be these two. So this is going to end up being x plus 4 and then an x minus 2. And then that is factored form. Remember, factoring is writing an expression as a product. What we've done is we've taken this expression, we've written an equivalent form as a product, which is the entire goal of factoring. All right, let's try another example here. So let's say we're going to start with 4a to the 5th minus 32a to the 4th and plus 48a to the 3rd power. All right, right away I notice just how this looks. There's a greatest common factor, and that's the first thing I should look for. So let's think about what can I take out of these, and let's focus on the numbers as numbers. Let's do the variables as variables. So first of all, with 4, 32, and 48, I think the largest thing I can take out of those is going to be a 4. And if I look at a to the 5th, a to the 4th, and a to the 3rd, the most a's I can take out of all of those is going to be 3 because that's the smallest power. So I'm going to take out an a to the 3rd. And then we're going to factor out that greatest common factor, which means I'm going to divide these out. So in this one, when I take a 4 out, that would leave a 1. When I divide out a cubed from a to the 5th, it's going to be a to the 2nd. When I divide the 4 out of 32, that's going to leave me with a minus 8. When I divide out a cubed out of a to the 4th, that would leave me with 1a. And when I divide a 4 out of 48, that's going to give me a 12. And then when I divide out the a cubed, there's going to be no a's left in this last term. And just like last one, we got to continue factoring until we cannot factor anymore. Here's a trinomial. We know how to factor trinomials. We can use the box for this. So this one, I'm just going to throw some numbers in the box. You may be able to do that mentally, and I have no problem with that. I'm just going to vet this one a little more closely here for anyone that's still developing that skill of factoring the trinomial. So I know that this equals a 12. I know these two multiply to 12. So my candidates are going to be 1 and 12, 2 and 6, and 3 and 4. And I also notice this is a plus and this is a minus. That tells me these two have to be negative because they have to multiply to be a positive, and at the same time these two have to give me a negative. So I think it ends up being a 6 and a 2 because this would give me minus 2a, minus 6a, which is going to give me my negative 8a. Let's review how we write our answer then. So we're always going to include our greatest common factor, which is going to be 4a cubed. And then we got to write this in factored form, which would be a minus 6 and an a minus 2. And there is this algebraic expression here written in completely factored form. All right, so what are your goals for today? We just added another piece to the puzzle. We just know that now when I look at a trinomial or whatever I get, one thing I can do to factor is I can take out a greatest common factor. Once we take out our greatest common factor, for example, 4a cubed in this one, it's important that we realize, hey, I can still continue to factor using my other methods. In this case, I use the box method to continue. So that's going to conclude our lecture for today. Hopefully that is making sense in terms of how these are breaking down algebraically. I will tell you right now, factoring is probably the most important algebraic skill that we will do in this course. It is highly necessary as we move forward in high school and college level mathematics.